Using the power property with exponential models to make predictions. To make a prediction about the independent variable t of an exponential model of the form f of t equals ab to the t power, we substitute the value for f of t and divide both sides of the equation by the coefficient a. Next, we take the log of both sides of the equation and use the power property to help solve for t. In this example, a person invests $2,000 in an account at 5% interest compounded annually. Let V equals f of t be the value in dollars of the account after t years or any fraction thereof. Part A. Find an equation of f. F of t is equal to ab to the t power. Since our equation is going to use t years, we need to find a and b. The person invests $2,000. That's the amount that we start with. That would be when time equals 0. That's going to make 2,000 our v-intercept. Since it's our v-intercept, we know that a will equal 2,000 since a represents the intercept. Now we need to figure out b. We know that the count is at 5% interest compounded annually. So what that means is we take 100% of our money and add to that 5% every year. So when calculating the interest for the next year, we're going to include 105% of the money from the previous year. Changing that to a decimal, we have 1.05, and that's going to give us our b. So our equation, f of t equals 2,000 parentheses 1.05 to the t power. In this example, we're going to do part B. What is the v-intercept? What does it mean in this situation? Our v-intercept is the amount that we start off with when t equals 0. As we've already found, v equals 2,000. Or I can write it as an ordered pair, 0, 2,000. So what does that mean in this situation? $2,000 is the principal. That's the amount of money we started with. Part C of the example. What will be the value of the investment in 5 years? To find the investment in 5 years, we need to let t equal 5. F of 5 equals 2,000 times 1.05 to the 5 power. We need to calculate, so we type in our information, 2,000 parenthesis 1.05 close parenthesis exponent 5, enter, and we get 2552.563125. Since we're dealing with money, we want 2 decimal places. So that's 2,556.56. So our investment in 5 years will be $2,552.56. Part D of the example. When will the value of the investment be $3,000? For this problem, f of t will equal to 3,000. So we won't be substituting in for t this time, we'll be substituting in for f of t, which will make our computation a little more complicated. 3,000 equals 2,000 times 1.05 to the t power. To solve this for t, our first step is to get rid of the a. So we want to divide both sides by 2,000. On the left, my 3,000 divided by 2,000 reduces to 3 over 2, and on the right it reduces to 1.05 to the t power. In order for us to solve for our exponent, we're going to need to take the log of both sides. So the log of 3 over 2 equals log of 1.05 to the t power. Using our power rule, that means we can write the t in front. Log of 3 over 2 equals t times log of 1.05. This allows us to solve for t by dividing both sides by the log of 1.05. So t equals log of 3 halves divided by the log of 1.05. And we're ready to calculate. So we start with log 3 divided by 2, close parenthesis, divided by log 1.05, close parenthesis, enter, and my result is 8.310386223. Rounding to the nearest tenth, that gives us 8.3. So the value of the investment will be $3,000 in 8.3 years. In this example, the U.S. annual production of ethanol used as fuel for automobiles was 6.5 billion gallons in 2007 and has grown by about 26% per year. Source: Department of Energy. Predict when the annual ethanol production will reach 33 billion gallons. First, we want to look at our exponential equation. F of t equals a b to the t power. In order for us to create our equation, we need to know a and we need to know b. We have 6.5 billion gallons in 2007. That's our start year. So that will be t equals 0. At t equals 0, f of t will equal 6.5. So our a is 6.5. From there, it has grown 26% per year. When we write b, we have to consider the previous years, so we have 100% plus 26%, which will give us 126%, which is 1.26. We want to predict when the ethanol production will reach 33 billion gallons. Since we're predicting when, we're looking for t. F of t will equal 33. So that's what we'll substitute once we've found our equation. Given what we know about a and b, f of t equals 6.5 times 1.26 to the t power. So now we're ready to do our math. We want to find t when f of t is 33. So 33 equals 6.5 times 1.26 to the t power. First, we want to divide by our a, so divide both sides by 6.5. I have 33 divided by 6.5 equals 1.26 to the t power. Now I want to take the log of both sides and use my power property. Log of 33 divided by 6.5 equals t times log of 1.26. The power property says that when I take the log, I can bring the power out in front, so I did two steps at once. Now I can divide both sides by the log of 1.26. So I have the log of 33 divided by 6.5, all divided by the log of 1.26. And now I'm ready to calculate. So I type log 33 divided by 6.5, close parenthesis, divided by log 1.26, close parenthesis. We will get a more accurate answer if we wait till the very end to do all of our math. Enter 7.029956671. If we round to the nearest tenth, that will give me 7.0. So t equals 7.0, or just 7. Since t equals 7, and we started in the year 2007, that gives us 2014. The ethanol production will reach 33 billion gallons in the year 2014. In this example, the timber harvest in the Tongass National Forest in Alaska have decayed approximately exponentially from 471 million board feet in 1990 to 19 million board feet in 2007. Source: U.S. Forest Service. Predict when the timber harvest will be 6 million board feet. So first let's talk about what we know. There were 471 million board feet in 1990. So if my time is my independent variable, in 1990 I had 471 million board feet. It's going to be easier to calculate if that's my year 0, because this also gives us our A for our exponential equation. We also know that we have 19 million board feet in 2007. So that tells us in 2007, we have 19 billion board feet. 2007 take away 1,990 is 17. So I have 1719. With those two pieces of information, I can find B. So using our exponential equation, f of t equals ab to the t power, I can substitute in for a. I also can substitute for t and f of t, my t being 17 and my f of t being 19. And now I can find b. 19 equals 471 times b to the 17 power. Divide both sides by 471. 19 divided by 471 equals b to the 17 power. Using the reciprocal of my power, if I take it to the 1/17th power, my exponents will cancel. So I also have to take my 19 over 471 to the 1/17th power. Calculating, parenthesis, 19 divided by 471, close parenthesis, exponent, parenthesis, 1 divided by 17, close parenthesis, enter. I get 0.82791218881. We want to use 4 decimal places, so B equals 0.8279. Now that we have that information, we can write our formula. F of t equals 471 times 0.8279, close parenthesis, to the t power. Now that we have this information, we can find our time. We're now ready to answer our question. We want to predict when the timber harvest will be 6 million board feet. So our 6 million that we have here is actually our f of t. We can substitute that into our equation and find what year we'll have the 6 million feet. So now that we have our equation, we can substitute 6 equals 471 parentheses 0.8279 to the t power. Divide both sides by 471. So 6 over 471 equals 0.8279 to the t power. Next step is to take the log of both sides. So I have the log of 6 over 471 equals t times the log of 0.8279. Dividing both sides by the log of 0.8279, we have the log of 6 over 471 divided by the log of 0.8279 equals t. So type log 6 divided by 471, close parenthesis, divided by log 0.8279, close parenthesis, enter, and I get 23.10193539. If we round to the nearest year, that gives us 23. So if t is 23, starting with 1990, I add 23 years, and I get 2013. So the timber harvest will be 6 million board feet in 2013. In this example, the number of Twitter employees are shown in Table 49 for various years. For the year 2008, the number of employees was 8, 2009, 29, 2010, 130, 2011, 350, 2012, 900. Source, allthingsd.com. Let f of t be the number of Twitter employees at t years since 2005. We want to use a graphing calculator to draw a scattergram of the data. Is it better to model the data using a linear or exponential function? So t is the number of years since 2005, so that means that 2008 would be 3 years, 2009 would be 4, 2010 would be 5, 2011 would be 6, and 2012 would be 7. So those are the values we want to type in L1, and then the number of employees we will type in L2. On our calculator, stat, and we want edit, and then we'll type our years, 3, 4, 5, 6, and 7. Arrow over to L2, and then we'll type the employees. 8, 29, 130, 350, and 900. Now we need to get a view of our data. So first, let's go to second y equals to make sure our stat plot is on. It's not. I'm going to press enter and then enter so that my on is highlighted. My X list is L1, my Y list is L2, so we're good. Click zoom and 9 for zoom stat. And now we have a graph of our data. Our graph looks like it's going to make more of a curve than a line. So an exponential function is going to be better for our data. Now that we've decided we want to use an exponential function, we can do part B of the example. Find an equation of f. We're going to use f of t equals a b to the t power. So the problem that we have here is we don't have a. We don't know how many employees they had at year 0. The best points to use for our curve will be the first one and then the fourth one. Using our equation f of t equals a b to the t, our first point 3, 8, and our fourth point 6, 350, we want to try to find b then a. So to find b, we have to write our proportion. First, we substitute what we know into our exponential equation. So that gives us 8 equals a b to the third power for our 0.38. For our 0.6350, we have 350 equals a b to the 6th power. When we set up our proportion, we want our larger exponent in the numerator to make it easier to solve. I have 350 divided by 8 equals a b to the 6th divided by a b to the 3rd. This reduces to 350 divided by 8 equals b to the 3rd. To get rid of my exponent, I need to take both sides to the 1/3 power, always the reciprocal of your exponent. And now I'm ready to calculate. Parenthesis, 350 divided by 8, close parenthesis, to the exponent of, open parenthesis, 1 divided by 3, close parenthesis. Enter, and I get 3.523649366. If we can't use our whole answer, you want to round to at least 4 decimal places. You want to have the most accurate answer you can. So B equals 3.5236. Now that we have B, we can find A. If I take my equation, 8 equals a b to the 3rd, and substitute in B, 8 equals a parentheses 3.5236 to the 3rd power. 8 divided by 3.5236 to the 3rd power equals A. Calculating, 8 divided by parenthesis. One of the options I have with the TI-83 and 84 calculator is that I can use the answer from the previous problem in my calculations. That way you can write a smaller decimal but then still have an accurate answer. So if I do second and negative, that's going to put A and S, which is the answer from the previous problem. Close parenthesis, exponent 3. Enter, and I get 0.1828571429, which rounds to 0.1829 for my A. Now that I have my A and my B, I can write my function for this equation. F of t equals 0.1829 parenthesis 3.5236 to the t power. I can check my equation by graphing this function onto my scatter plot. Go to y equals 0.1829 parenthesis 3.5236 to the power of my exponent. Graph. And this curve is a good approximate of my data. In part C of this example, we want to predict the number of Twitter employees in 2014. So first we need to figure out what 2014 is. Well, we started with the year 2005, so 2014 is 9 years since 2005, and that's our value for t. Substituting in for t, so I have f of 9 equals 0.1829 times 3.5236 to the 9 power. We want to calculate that. So type in 0.1829 parenthesis 3.5236 0.5236, close parenthesis, to the 9th power, and I get 15314.15778. Rounding to the nearest person, I have 15,314 people working at Twitter in 2014. In Part D of this example, predict when the number of Twitter employees will equal 394,000, which is the population of Cleveland, Ohio. So going back to our formula, 394,000 is going to be our f of t. So substituting, we have 394,000 equals 0.1829 times 3.5236 to the t power. So our first step is divide by a. So I have 394,000 divided by 0.1829 equals 3.5236 to the t power. Take the log of both sides. Log of 394,000 divided by 0.1829 equals t times log of 3.5236. Dividing both sides by the log of 3.5236, t will equal log of 394,000 divided by 0.1829 divided by log of 3.5236. And that's what we want to calculate. So we start with log 394,000 divided by 0.1829, close parenthesis, divide, log again, 3.5236, close parenthesis, enter, and we get 11.578496662. So if we round that to the nearest year, that rounds to 12. So if t equals 12, 2005 plus 12 gives us 2017. So our estimate is that the employees of Twitter will equal 394,000 in 2017. Using the power property with exponential models to make predictions. The difference between this section and sections that we've done in the past where we make predictions is that we are making predictions about our time, which means our variable is in the exponent. When we are dealing with the exponential function, you want to make sure you divide both sides by your a so that your exponent and its base are by itself. Then we can get rid of the exponent by taking both sides to the reciprocal of our exponent. So if our time was 4, we take both sides to the 1/4. That way we can solve for t.